Solve each equation by factoring. So what we're going to do is we're going to do factoring just like you learned to do in Module 7, I believe. Or no, excuse me, Module 6. So if you need to review this technique, you can always go back to the Mod 6 video review series and it'll show you how to factor. I'm going to show you again here. But what we're going to do is we're going to turn this into a multiplication problem. And the first step is to make sure that our quadratic trinomial is equal to 0, which it is here. So I'm just going to copy it down so that we have a version to work with.
Anna Abbott, Joni Bolden, please call the main office.
And then from there what we're going to do is we're going to take the coefficient of the squared term and the constant term, the term that does not have a variable with it, we're going to multiply those. So here we take 1 times negative 10, which is going to give us negative 10. And I'm just going to write that off to the side. And what we're going to do is we're going to come up with a full list of factors, things you can multiply together to get a value of negative 10. So I could do 1 times 10, I could do 2 times 5, and that's it. But this needs to be negative 10, so this could be negative 1 times negative, or negative 1 times positive 10, or negative 2 times positive 5, or it could be positive 1 times negative 10, or positive 2 times negative 5. So I have to include those options as well. So those are all the numbers that will multiply together to give me those. And what I want to look for is a combination of these numbers, so this pair, or this pair, or this pair, that adds up to the b term, the coefficient that's in front of our linear term. That's the variable just by itself. So in this case, I'm looking for a pair of these that add up to 3. And if I look, negative 2 plus 5 is in fact going to give us 3. So those are my two right there. And what I'm going to do is I'm going to bust up the b here. That is, I'm going to take this b term, that plus 3v, and turn it into these two. So I'll rewrite this as v squared, and now instead of plus 3v, I'm going to say minus 2v, don't forget the v, plus 5v minus 10 equals 0. So I split that plus 3v up into these two parts. And now what I'm going to do is I'm going to take this first part here, and I'm going to factor it, and I'm going to take the second part here, and I'm going to factor it as well. V squared is v times v. 2v is 2 times v. And so now what I'm going to do is I'm going to see what they have in common. They both have a v, so I'm going to pull that to the outside. I've used up a v there, so I have a v left, minus 2. So v squared minus 2v is the same thing as saying v times v minus 2. Now, over here, I have 5v, which is 5 times v, 10, which is 2 times 5. I look for what they have in common. They both have a 5, so I'm going to write that on the outside, and then what's left will be v minus 2. And all of this is still equal to 0. And I can rewrite this as a distributive property thing. I take the two that are on the outside, and I say v plus 5 times, and then here's this thing that repeats, v minus 2, all of which is still equal to 0. Alright, so all I've done is factor this. If this was confusing because this is just the most brief overview, assuming that you still remember how to do some of this, I encourage you to go back to the Module 6 review and look at how to factor. There's a more detailed video there that'll show you how to do this in more detail. But once we get to this point right here, now we can do something new. We can solve this. And what happens is this. If this times this is going to equal 0, either that's 0 or that's 0. So I can set up two problems from this. I can say that either v plus 5 equals 0, because that would give me 0 times something, which would give me 0, or I can say that v minus 2 is equal to 0. One of those things has to be true. And now I can solve for v in both cases. Over here, to solve for v, I just subtract 5 from each side. So v would be negative 5. Over here, if I add 2 to each side, that allows me to solve for v, and v would be 2. So there are my two solutions, v equals negative 5 or v equals 2. So let's look at this again for number 7. I'll do this one a little more quickly so that you can see all the steps going at once. I need to have this thing equal to 0, so in order to do that, I'm going to move this negative 3 over here. And when I do that, I'm going to be adding 3 to both sides. And what I'm going to get is x squared plus x, these cancel out, is equal to 0. Now I need to factor this, and it turns out that over here I had this more complicated term. This one's pretty easy to factor. The only thing these have in common is an x. If I expand these out, like I did before, you can see they have an x in common. So I pull that to the outside. That has nothing left. So it's going to be x plus 1 equals 0. And now, all I have to do is say that either this is equal to 0 or that's equal to 0. So I have two possibilities. Either that part right there equals 0, and that's already solved, or x plus 1 equals 0, and I can solve that very quickly and find that x would be negative 1. So there are my two solutions to that problem. Now there's a third type of problem that you might see here. I'll just throw in an extra one. What if we see something that looks like this? Let's say a squared minus 36 equals 0. You can work this in the same way as we worked problem 6 if you realize that b, if we're finding, a in this case would be 1, c would be negative 36, b would be 0 in this case. So we would take 1 times negative 36, and then we'd look at all the factors of negative 36 to see which ones add up to 0, because that middle term is missing. But there's an easier way to do this. This is what we call a difference of two squares. Difference means they're being subtracted. Squares, in this case, means that this is a perfect square. The square root of a squared is just a. And this is a perfect square. The square root of 36 is 6. When you see this, you can just very quickly set it up as the square root of the first one plus the square root of the last one times the square root of the first one minus the square root of the last one. Set that equal to 0. Now we have our two problems. Either a plus 6 equals 0 or a minus 6 equals 0. If it's the first case, we can solve and find that a would be negative 6. If it's the second case, we solve it and find that a would be positive 6. And there would be our two answers.